Hello, kiddos. It is time for some algebra. So this is the extra credit. Lucky for you, I'm going to do the review too. So, I know. Hold in the excitement. Okay, so we are going to go on to start right off the bat with the simplifying of these powers that are negative. Remember, it doesn't matter if the number is negative. Out front, like down here, if there's -6, that we don't have to move. The problem is when the power is negative. That we do have to move. That's not simplified. So the only thing you have to do is keep it exactly the same, is to switch it. So right here, that's on the top of a fraction really, over 1. You just need to put it in the bottom of the fraction. So if you notice everything's exactly the same, it's just the power changed to positive. And then you go ahead and do it. So 3 to the second is not 6, right, class? It's 9. All right, number 2, evaluate this. So first substitute in, remember when you're substituting, always put it in parentheses. That just prevents problems and losing half points here and there because you lost or added negatives that weren't supposed to be there because you forgot your parentheses. Now, we have the same problem as up here. So I'm going to go ahead, put 1 over -6 stays. Remember, I don't care about that negative. It's that power that I don't want to be negative. Now I go ahead and do that, and I do -6 times -6, which is a positive 36. All right. Moving on. Simplify A. Now, and you really need to understand what it's saying. It's saying A times, there's a multiply in there, 8 times A to the 0. Okay, so there's 2 things here. We got 8, and we're multiplying it by an A to the 0. Keep those separate. It's not that. Okay, the only thing raised to the 0 is the A, and anything raised to the 0 is 1. So I really have 8 times 1, which is 8. All right, we're going to write this as a power of 10. Remember, when you're writing these just normal numbers like 100,000, million, all these big numbers, if you want to think of the shortcut, it's the number of zeros that you see. It just doesn't work when it's small. 1, 2, 3, 4, 5, meaning a 0.000001. In other words, the long way, though, is that you have to find the decimal and go all the way until you get to the number 1. 1, 2, 3, 4, 5. Okay, so you still can get it that way. 10 to the 5th. In 2000, the population of Forest, Virginia was about 8,000 people. Write this population in scientific notation. Okay, so that's something times 10 to the something. Those are the 2 spots you need to fill it in. These parts stay the same. Find my decimal. I'm going to go 1, 2, 3 until that number is 1 to 9. In this case, it's 8. And I'm going to count how many spots I went, which was 3. And did it get bigger or smaller? Right, this number got smaller, so this number should get bigger. Remember, they counteract each other, so it's 8 times 10 to the 3rd. 5 times 10 to the -4th. Okay, write it in standard form. Okay, that's standard form. When it's just written like a normal number, that's scientific notation. So they gave us the scientific notation. Now we got to flip it back. So I'm going to take my number, which is 5, and I'll put my decimal in, which is right there. And now it's -4. So which direction do I need to go? Is my number going to get, because it's a negative, going to get smaller or bigger? My final number is going to get smaller because of the negative. If it was positive 4, I would get bigger. So I know smaller is going to go this direction. So 1 hop over the 5, 2, 3, and 4. So my answer is point. I'm going to rewrite it so it's very clear where my decimal is. All right, going up to the top. 5 to the second times 5 to the third. Excuse me. So we have 2 with the same what, class? New color. Let's look at that one. Same base, and they're multiplied. So what do I do with powers? We add the powers. So it's going to be 5 raised to the whatever 2 plus 3 is. In this case, it's 5 as well. Then you can just leave it like that. That's fine. If you wanted to expand it out, that's fine as well. Either would be acceptable. Now the difference here is I only have how many bases? 1. I have 4. Up here I had 2 bases, right here and here. Okay, so it's 1 base and it's raised power to a power. When it's a power raised to a power, we don't add, we multiply. So now I have 4 raised to the 6th power, or you can put that in expanded form, which is 4096. Either is 100% correct. Okay, so here we go. It's this whole thing. You need to keep these things separate, class, because it's everything in the parenthesis that's raised to the 5th power. How many things are in there? Well, we got a 2 times an a to the 3rd. So we got 2 things in there. So I first have to raise the 2 to the 5th and then multiply it by the a to the 3rd to the 5th. So 2 to the 5th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. And this is a power to a power, so I am multiplying. So it's a to the 50. All right, the next one. In 2000, the population of Geneseo, New York, was about 7,600 people. The population of the entire state of New York was about 2.5 times 10 to the 3rd times larger than the population of Geneseo. What was the population of New York in 2000? Okay, so first you have to figure out what you're doing. It said the population of New York was this many times larger than this. So I have 2.5 times 10 to the 3rd times that. Now notice it says write your answer in scientific notation. So the first thing I'm going to do actually is get this in scientific notation, because then I can combine things. Times decimals here, 1, 2, 3, so I have 7.6 times 10 to the 3rd. Now remember, since these are all multiplied, I can do them in any order. So I can put these together, 2.5 times 7.6, and get 19 times, and then I can put these together. I got 10 to the 3rd times 10 to the 3rd. That goes back up to something like this, where the bases are the same, and I'm multiplying and adding the exponents, right? 10 to the 3rd times 10 to the 3rd. We add them, 10 to the 6th. Question is it in scientific notation? Not yet. We have to do one thing, right? Because my decimal's here, so the number before the decimal is 19. And we have to have the number before the decimal be 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's it. Those are your only options. So I need to go back one spot. So did I make this number bigger or smaller? Now I went from 19 to 1.9. So I made this one smaller. So what do I have to do with this one? Make it bigger by that same amount. So I'm going to raise it 1 to 7. That's your final answer. All right, looking at 11 here. So we've got a to the 16th over a to the 4th. Again, it's kind of like these. I'm putting this back up here. 2 bases, when you multiplied, what did we do? We added them. Well, now I've got two bases, but instead we're dividing. So in this case, we would actually subtract instead of adding, like we did over here. So another way I like to think of it also is you have 16 A's in the top and you have 4 A's in the bottom. Remember, we went through this where I would list them all out, right? Forever, or 16 of them, and then 4 of these are down here. And then every A over A, those cancel, right? So the 4 A's in the bottom cancel out with 4 A's on the top. So how many do you have left? You have 12 A's left over. Where? In the top or the bottom? In the top. So, I mean, ideally, yes, you're subtracting, but you can also look at that in a different way, because I oftentimes will just be like, okay, I got 16 in the top, 4 in the bottom. 4 of those are going to cancel out, so I'm going to have 12 left on the top. Okay? And if these were flipped, if we had 8 to the 4th over 8 to the 12th, 4 of them still cancel out, but instead I got the extras downstairs now, right? So I'll get 8 to the 12th, I'm sorry, if this was a 16. I'll have 8 to the 12th down here, and then what do you put here? Just 1. You don't put an A there. The A's are gone up there. Okay? When we look at the next one, again, you need to notice the parenthesis. Everything in the parenthesis, I'm going to start highlighting that so that jumps off a little bit more to you, has to be raised to the second power. Everything. There is a 4 times a y to the 6th and an x to the 3rd. There are 3 different things in there, and they all need to be raised to the second power. So I'm going to have 4 raised to the second power. And you're going to have y to the 6th raised to the second power. And you're going to have x to the 3rd raised to the second power. And I'm not necessarily saying you have to even write all this out every time, but the problem is everybody will square the y, and they will maybe square the x, but oftentimes that poor little 4 is left all alone, and they leave it a 4. Like it's a less than number. Okay? It's just as important as the y and the x, people. Don't leave it out. So 4 to the 2nd is 16. And 6 to the 2nd, remember, that's a power to a power. You multiply, it's y to the 12th. And power to a power, that's x to the 6th. All done. So then what happens when you have something in parentheses like this, and it's all raised to a negative power? Well, what you want to do is first get rid of this negative, not the 3. And it wouldn't matter if there were negatives inside here, in front of these numbers. Don't care. I only care when the power is a negative. Now, I'm going to fix that. So I'm going to take and do the reciprocal of what's inside exactly. Notice that. I just did the exact same thing. But now instead of a negative 3, I have a positive 3. And we usually don't write the positive, so I don't want to confuse anyone, so I'm just going to get rid of that. Okay. Then again, we have to look inside because everything inside gets raised to the 3rd power. So how many things are in there? I've got a b to the 5th, and I've got a 2. They both get raised to the 3rd power. So I've got a b to the 5th to the 3rd, and I've got a 2 to the 3rd. Power to a power, we multiply. I get b to the 15th over 2 times 2 times 2, which is 8. All done. All right, simplify the quotient. Well, I see this division, so I'm going to write it as a division, as a fraction. 6.4 times 10 to the 9th over 1.6 times 10 to the negative 3rd. Because I can rewrite it that way. All right, now I'm going to, because at multiply and divide, you can do in any order. It doesn't have to be in the same order. we're going to split this up and break this right into our own little fractions here. Put our own little parentheses in it, because I can do that first. Okay, so I'm going to take my little handy dandy calculator and do 6.4 divided by 1.6, which is 4, times, because I have a times here. Now what will this be? See, that's a little trickier because it's not like the one up here where you're like, I got 16 in the top, 4 in the bottom. Okay, I got 12 left up here. One of them's a negative. So we got to get that to be positive before we can put them together. Or you could subtract them, as I mentioned up here. 16 minus 4 is 12. You can do that down here, but you got to be very careful. 9 minus a negative 3. That is 12. Now let's say that part you didn't like. You didn't like thinking of that. I'm just making this bigger. Then that's okay. Let's just make this 10 to the negative third positive. How do we do that? We move it upstairs and make it a positive 3. So then I can look at it this way. I got 10 to the 9th times 10 to the 3rd. And what do I do when I have two bases and they're both multiplied? I add the exponents. So there's a couple different ways that all of these can be thought about, and you kind of need to see which one meshes more with your own thinking. Okay? All right. Now we're getting into these powers that are fractions. Remember, when you have a power, let's just say 36 to the 3/4. I'm just making this one up for 1 second. That is the power, and the bottom number is the root. Okay, so when you do this, that is the root, the little number that goes there. That is the power. So I can either put it here, or I could have put it out here. Either way. There's no order that you have to do those in. So let's take a look at 36 to the 1/2. Now, if you recall, 36 to the 1/2 is the really lovely one because the power is 1. So 36 to the 1 is just 36. And the root is 2, which is just a normal square root. We don't even usually write the 2 in there. It's just a square root. This is equal to this, same thing. It's an assumed little 2 there. So square root of 36 is 6, all done. So let's look at this one now. Okay, so what is the root and what is the power? The root is the bottom, remember? Oops. God bless me. All right, the root is the bottom and the power is the top. So I can put again the 3 here, or I can put it out here. I'm going to put it out here because I'm already seeing that I know what the square root of 25 is. And I think it's much easier to get the square root of 25 than to get the cubed power and then try to do the square root of 25. So I'm going to do that first. Square root of 25 is 5. Then I'm going to raise it to the 3rd power, which is 125. 5 times 5 times 5. All right. Now, in 17, whenever you look at these, it may be helpful if you use 2 different color highlighters. I think that might help you break this up because you have this, that, oopsie, I'm not on this one. You have that, and then you have that. Okay, those are the 2 different things, and they're being multiplied together, but that's kind of how you need to view these. The x is raised to the 3rd, which is raised to the 3rd. And the y has a power of 5 and a root of 5. So I'm just going to rewrite them separately so that you can see them a little more clearly. And of course, I'd recommend you do that because when you split them, it's a little easier to see because power to a power, what do? You multiply. And what is a third of 3, class? 1, right? A third of 3. If you had 3 pizzas, what's a third of them? 1 whole. Okay, so I have just x to the first power, or x. And then when you have this set up, remember you can also do the power divided by the root. Remember, the power, oops, up here, the power divided by the root. And it turns out super lovely in here because what's 5 divided by 5? Y to the 1. It simplifies down to that. Okay. The goal on those is just, it looks like a mess until you really realize that I've got the x and this stuff goes with the x and this stuff goes with the y, and try to look at them separately. I think that'll help you. Which polynomial has a leading coefficient of 1? Remember, leading coefficient, if you need to write them, and first you write them in order of, like if I was going to take this one, the powers. So that is y to the second, that is y, that is 7. So it would be 5 y to the second plus y minus 7. So it's listed in descending order, and then the leading coefficient is 5. So it's not that one, because I need to get 1. And if I look at this, that would be written as 2x to the third plus 1. So the leading coefficient would be 2. It's not that one. And I'm just going to do this bottom one here. You put the negative, don't forget that, y to the second, plus 5y minus 4. Remember, what's before it goes with it. So my leading coefficient here is -1. Not that. Better be this one or we did something wrong. The highest power here is x to the third plus 3x squared plus 2x. The leading coefficient is 1. Yay. Classify this polynomial. Remember, poly means many. Okay. But when they want you to classify it to its degree and the number of terms. Okay, so first, how many terms are there? Remember, those are the things that are added or subtracted together. So there's 1. There's 2 right through there. And wishing I had a different color, but I don't, because those are not like terms, the yellows. But there's 3 is basically what I'm trying to say. And the degree, remember that's winner, winner, chicken dinner. Which one has the highest power? You don't add them all together. What is the degree of the first yellow term? 2. What's the degree of the pink term? 1. What's the degree of the constant? 0. Remember, all constants have a degree of 0. So we're only looking at the power of the variable. And this x has a power of 1. That's why it's 1. This x has a power of 2. If there was a y in there, I mean, you just add all the variable powers. But this doesn't play into it. So I do not add them. Okay, I take my highest one. There's my winner, 2. Now we have to classify it. So when it has 3 terms, it's not a monomial because that's 1, and a binomial is 2. So this is definitely a trinomial. You usually put that second. I'm not going to matter if you mix these up. I'm not going to matter? What did that mean? I'm not going to care if you mix these up. Now the degree is 2. And that, when it's a degree of 2, is always a quadratic. If it's a degree of 1, what is it? Linear. Gives us a line. Quadratic gives us a parabola. You'll get more into that soon. Okay. Last page. Brett has 100 feet of fence. Wait, you know what? I believe it's time for a commercial break. I decided today to show you one of my favorite kids' books that I used to read to my kids. You know, last week. No, I'm just kidding. But I keep these for my future grandchildren. Caps for sale. Who has read Caps for Sale? It is an awesome book. Caps for Sale, Caps for Sale. I think it was 50 cents a cap. Let me see. If I'm remembering right, I read it only 8,000 times. Let me see what he says. Oh, I'm right. I didn't even look, I promise. Caps for sale, 50 cents a cap. Okay. So if you have younger siblings, I highly recommend you get this book and read that to them. Thank you for that special commercial break. I shall now move on to Brett. Brett, who has 100 feet of fence with which to make a rectangular cage for his dog. The area of the cage in square feet is given by the polynomial negative w squared plus 50w, where w is the width of the cage in feet. What is the area of the cage if the width is 8 feet? Now, I think I mentioned this in class, but I'm going to mention it again, is that sometimes we do these different kind of wordy problems, and it's not that they're real difficult, but they want you to understand different situations where you might use these quadratic binomials and things like that. So they actually even gave it to you. They said here, the area is given by that. So they basically told you that that's how you figure out the area. And then they told you that W is the width of the cage in feet. So their question, if you look, what is the area of the cage if the width is 8 feet? So it literally is just substituting an 8 in for the W, because they just told you that W is 8, and seeing what you get. Now you got to be very careful on this with this negative here, because the negative is not squared. If the negative was squared, you would have had parentheses around this. So you have a negative 8 squared plus 50 times 8. Okay, so I go here, and the negative is still there. Not touching that. But I am going to square the 8. 64. Plus 50 times 8. We got to do order of operations. Do you know how many people add these two before they multiply? No, 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 no. Cannot do that. 400 and negative 64 plus 400 is 336. And since we're talking area and we're talking feet, it would be feet squared. And wow, it's a multiple choice even. Well, isn't that slick? There we go. Work must be shown anyway. Okay, remember there was difference here. I need you to see this difference. See this parenthesis, this parenthesis, this parenthesis, this parenthesis. What's between this one? Plus. What's between this one? Multiplication. What's between these two? Subtraction. These follow different rules than these. Okay, so when you're looking at adding or subtracting, it's about first getting rid of the parenthesis and then combining like terms. Okay, so in this case, when it's a plus, remember what's before the parenthesis is a 1 and a 1. And when you distribute a 1 through everything, it won't change anything. 1 times anything is itself. So you are basically rewriting this without your parentheses. In this case, the parentheses actually didn't change anything. Now I look for like terms. And I say I have a 1 point, I have those two. 1.2 x to the 5th and 3.7 x to the 5th. So that is a 4.9 x to the 5th. Do I have any other x to the thirds? No, I do not. So I'm just going to rewrite that one. And then, oops, I do have this. So I have a 3, a whole number 3, minus a 0.7. What is that? Hoping you can do that in your head, but if not, that's okay. 2.3. And again, There aren't that many multiple choice on the test, so I don't want you relying on that. Let's see here, it's B. Okay. Seems to be more in here. Now, subtraction's a different story, isn't it? Although what's before this one is a 1, so I can just rewrite it. It's before this one is a negative 1. So I have to distribute that negative 1 through both, and what it does is it just switches the sign. So now instead of having a negative 5a squared, I have a positive 5a squared. Instead of having a positive 3, I have a negative 3. Now I'm going to go through and combine like terms. Do I have any other a squareds? Yeah, make sure you take the sign before it. So 7a squared plus 5a squared is 12a squared. Do I have any other a's? No, I don't. So it's gone, that's gone, that's gone. Then I have 6 minus 3. Don't lose your signs. That's plus 3. So it looks like G is our answer. If you are listening, I am going to tell you a letter to write down. And if you tell me this letter in class, I might give you, well, no, I'm going to give you extra credit, but I'm going to know you watched the video. How about that? So the special letter is M. So write down M right now, next to problem 22. All right, 23. When we do this, what is the operation between them all? I think I'm slowing down. I'm talking slower. I better speed it up, huh? All right, I think I'm falling asleep or something. Multiplying. So again, we're not actually adding or subtracting in here. We've moved on to multiplying, which is all of these. So when I multiply these, I'm not trying to combine like terms here because we're multiplying. It's not like these ones above where you were combining like terms. Okay, and these are all added or subtracted together. We're not doing that. We're multiplying these. So you straight up multiply all the numbers together, combine all the r's, combine all the s's, and you're done. So negative 8 times 4 is a negative 32, times a negative 2 is a positive 64. We have an r to the first and an r to the sixth. When I have an r to the first times an r to the sixth, I get an r to the seventh. We add them. Then I have s to the second, s to the third, s to the third. We add all the exponents. 2 plus 3 is 5, plus 3 is 8. All right. A rectangle has a width. As soon as you see something, draw yourself a picture. A rectangle has a width, so just assume that's the smaller side. Width, W. Label it. Its length is 5 units less than the width, or, and then they give it to you right here. Not that you guys couldn't have figured that out on your own. 5 less than the width would be that. Write a polynomial for the area of the rectangle. So how do you get area of a rectangle? Area of a rectangle is length times width. Great. What's my length? And what's my width? I'm going to actually, my length is, I'm going to put my width first. Width times, because again, multiply, you can do it in any order. So I'm just going to put the single one first and the other one, so it looks similar to what you're used to seeing. All you have to do is multiply those. Okay, we're distributing. W times W is W, what? Add the powers to the second. Minus W times 5. And we write the number first, 5W. That's it. A equals. Okay, so did we do it right? A polynomial. Yep, that's a polynomial for the area of this rectangle. This times this. Done. Okay, when we get to 25, time to bring in the orange. Time to bring in the big guns here. All right. We have how many terms in here? 2. How many terms? 2. How many terms should I get after I multiply them? 4. 2 times 2. Notice it's multiply here. So again, you can use, if you like, FOIL. First, outside, inside, and last. So you can multiply the first terms, then the outside terms, then the inside terms, and then the last, which is the same as basically also the way I've said it before, which is multiplying everything in here by everything in here. It's just keeping it more organized. So let's try it using FOIL. So let's multiply the first terms. 3x times 2x. So 3 times 2 is 6. And x to the first times x to the first is x to the second. You add the exponents. Now let's do the outside terms. 3x times 6 is, and I'm going to do the positive because they're both positive, so I'm going to make that an add 18x. Now let's do our inside terms. Negative, make sure the negative comes with you, negative 2 times 2x is a negative 4x. Again, plus a negative is the same as subtract. And last terms, negative 2 times 6 is a negative 12. 1, 2, 3, 4. I have my 4 terms. The last thing I need to do is see if there are like terms. There are like terms. I have a plus 18x. That's a bad choice of color because now you can hardly see it. And I get 6x squared. That's still there, but 8 plus 18x and minus 4x give me a plus 14x and then minus 12. Okay. Now we need to go on to b plus 3 to the third. Remember, this is adding. You cannot just cube these each like you did. Let me see where it was. Right here. 4 to the second, y to the 6 to the second. Okay, we were multiplying here. Now we're adding. It's not that easy. Okay, you have to literally write this out as a third, which is b plus 3 times b plus 3 times b plus 3. Yes, you have to do it the long way. Okay, so I'm actually going to start by multiplying these two first. I'm just going to leave this guy out front. I'm not going to do anything with him right now. And I'm going to use my FOIL method. b times b, add the exponents, is b to the second. Outside, b times 3 is 3b. Inside, 3 times b is 3b. Last, 3 times 3, 9. Are there any like terms? Yes, there are, those two. So 3b and 3b is 6b, because we're adding. Put them in parentheses and drop that guy down. Oh, I think I'm in heaven. Do you hear those harps? Hang on a second. A moment, please. Oh, God, it's my son. Hang on one second. Hello? Hey, I'm recording. What's up? What do you need? Yeah. Not yet. I gotta go. Not yet. Not yet. Okay, thanks. Bye. Sorry about that interruption. All right. B times b to the second, because now I got to take both of these and multiply it by all three of these. So I'm going to end up with 6 terms. So b to the first times b to the second is b to the third. B to the first times 6b, I'm sorry, is positive 6b to the second. B to the first times 9 is 9b. Plus, now we go to the 3. 3 times b to the second is 3b to the second. Plus 3 times 6b is 18b. Plus 3 times 9 is 27. Isn't it nice? There's no negatives to get you all mixed up in this one. Now we just got to make sure we put all the things together. So are there any other b to the thirds? No. Okay, cross that off. But there's a plus 6b squared and a plus 3b squared. So I've got a plus 9b squared. And then I've got a plus 9b and a plus 18b. So that is a plus 27b. And then there's the plus 27 at the end. And there is your grand finale answer. As beautiful as that is. 3 cheers, yes. All right. Now, here we go again. Multiply this. Don't get tricked. There is adding and subtracting in the middle. You have to rewrite it. 6x minus 7y times 6x minus 7y. Now, let me get out a different color. Where's my blue? Foil. I can use foil when there's 2 and 2. So, first, 6x times 6x is 36x to the second. Outside, 6x times negative 7y is a negative 42xy. Inside, negative 7y, and 6x is a negative 42yx. And negative 7y and a negative 7y is a plus 49y squared. All right, like terms, you bet. So we have this one and this one. And yes, they are like terms. Just because one's xy and one's yx, that's the same thing. And so we have 36x squared minus 84yx and plus 49y squared. Now, if you would have noticed, this is a perfect square trinomial. And as I told you in class, you can always work it through the long way. Or if you would have noticed that, you could have squared this, gotten 36x squared, squared this, gotten 49y squared, multiplied these, gotten negative 42xy, and doubled it, negative 84xy. So you will get more familiar with these as we go. Kudos to you if you notice it, but it's not reliant on you to notice it at this point. Now, this one, which product results in this? Which product? So this one is one of the two. We talked about perfect square trinomials, and we also talked about the difference of squares, difference of squares. What was difference mean? Again, what does difference mean again? It means subtract. Okay, do I have that? Yes. Squares That means, do I have two things here that when you take the square root, you get just a normal whole thing? Like, what is the square root of x squared? Square root of x squared is x. Good, that came out nice. How about the square root of 1? Does that come out nice? Yeah, it's 1. When that happens, it's so slick because we know that the product that they multiplied, like we've been multiplying up here, multiplying these, multiplying these, multiplying these. We've been doing this whole page. And they said, what product? What things do you multiply to get this? So they're hoping and wanting you to notice this difference of two perfect squares. Because when you notice it, these are your two winners. X and 1, X and 1. So you literally take the square root of each part, and it goes in there, and 1 is positive and 1 is negative. And that's why there's no third term in the middle. It's just the outside one and the last one. Okay, so let's just do one more. If I had x squared minus 16, that's another example of one. Because I can split it up again. X, what's square root of 16? 4, 1's positive, 1's negative. I can do this all day long. What's this one? X squared minus 9. X, square root of 9, 3, 1's positive, 1's negative. How about if I said the x squared plus 9? No, we can't do that. That's not a difference. So we can't take the shortcut on those. Okay? Excellent job. The last three letters of the word is A-T-H, A-T-H. So you can combine all those and write the word that you got from today's lesson at the very, very small. Put it up by your name. Okay, all four letters should be up by your name. That's going to be code, so I will know who watched the video. Don't tell anyone. Have a good day. See ya when I do the review, which I'm going to do right now. Bye-bye.